So look at this problem. The coefficient of x square in one expansion is given as 13 by 2. You have to find the coefficient of x cube. So again, it's not a direct binomial expansion, right? There's a product multiplied, etc. So, and there's one more term you can see that is a here, correct? So probably we can figure out a once we get this one information already given, and then we have to find the coefficient of x cube. So what we are interested in, maximum power is x cube. So if you're getting powers higher than that, we'll start to ignore them. Okay, let's try to multiply. So I'll keep these terms because everything is below x cube, right? In the expansion, let us look at the expansion. So it is half power 5. Okay. NC1, n is 5. Okay, so I'll directly write that. 5C1, which is 5. Okay, let me write it down so that there's no confusion later. So half power 4 into 2x. Okay, there's a minus sign which I already considered outside. So I'm not going to write it again. Plus. Now it's 5C2 half cube 2x whole square. Okay, it's minus 2x, but I always consider negative sign directly. So again, see this minus sign is considered. 5C3 half square 2x cube. I'll stop here, even though there is other terms. As I told, we're interested in max x cube. Okay, to figure out a, we don't even need x cube because it's given as the coefficient of x square. But because in a problem we want the coefficient of x cube, I'm just stopping here. Okay. So let us continue to try to find the coefficient of x square. Okay. So one of the possibilities, this into this, right? So let me write it down. So it is 3 by 2 or 5. Can I write it 32? Yeah. 3 by 32 x square. That is one possibility which is taken care of. Okay, already marked. Second possibility, this term into x term. This is a term, right? So it is minus 5 by 2 power 4 is there. 2 power 4 is nothing but 16. Okay, but there's a 2 here. Fine. So it's into 2 into x square. This x and this x into a. Fine. Okay. What else? What else? We have this 1. So 1 into x power 2 will still give me the same answer. That is the coefficient of x square. Again, it will be x square. So 5C2, let me write it down now. Plus 5 into 4 divided by 2. Okay. 1 by 2 cube. So it is 1 by 8 into 2 square 4 into x square. Okay. Into this term is 1, right? So it remains as it is. So we are given the coefficient of x square. So this is equal to 13 by 2 x square. Its coefficient. So I just multiplied with x square. So we can just remove this x square altogether. Okay. So this is the equation. There's only one unknown a. We just have to simplify. Okay. So 3 by 32 remains as it is. Here you can see that I can cancel off this 2 and make it 8. But just think about it. We would want a denominator anyways in terms of 32. Okay. But let me keep it as it is right now. 5a by 8. Fine. Next one. Plus 8. This 4 ones are 4 twos are, right? This 4, 2 and 2 again is 4. Okay. So all that remains is 5 is equal to 13 by 2. Can I rearrange? So 5a by 8, I'll take the other side. It's 5a by 8. Okay. So what do we have? 3 by 32 plus 5 minus 13 by 2. Okay. If you want, you can take a common LCM, right? Or you can just simplify these two first, okay, just to make it easier. So this is 10 minus 13 by 2 minus 3 by 2. Makes sense, right? This is 6.5 minus 3 by 2 is minus 1. Remaining is 3 by 32. Again, take the LCM. So it is 6 minus, the denominator is 64. So 3 into 2 is 6. 32 into 3 is 96. Okay. So if you kept the LCM as 32, correct, calculation would have been easier. That's all. So Let's take the LCM. LCM is 32. Okay. So 2 16s are 32. So, right? Here I need not multiply anything. So it is nothing but 3. Right? For the other term, it is 3 times 16. Okay. Or it is 52 or 42. 32, sorry, 48. Yeah. So this is nothing but minus, say, 45 by 32. Okay. So this is equal to 5 by 8. 5a by 8. Okay. Now you can directly simplify here. 5, if I divide by 5, this is 9. Okay. If I divide by 8, that is the denominator. This is 4. So I got 8. So a is nothing but minus 9 by 4. Now only one part of the problem is done. We just figured out what is a. Now we have to figure out what is the coefficient of x cube. I know that to get the coefficient of x cube, we want a somewhere, right? So we figured out a first. Okay. Now we are looking at x cubed. Let's try to figure out. To get x cubed, see here the maximum power is x square. So I have to multiply x square with x term to get it, right? Let me just remove this yellow part so that there's no confusion. So what am I multiplying here? These two are multiplying to get x cubed. So just write the terms. 3 into 5c1, which is 5, into half power 4, which is 1 by, say, 16, into 2x. Now, this is x here, and this is x square there, so total x cube. Anyway, we're figuring out x cube terms. Okay. Next is this x into x square term. Okay. So I'll get a. Let me write a first. Okay. One thing we forgot here, there's a negative sign, so this will be negative. Okay. Here there's positive, both are positive, so no issues. So a into 5c2, 5 into 4 by 2 into 1 by 8 into 2 square 4 into x cube. X cube from this x square and this x. Okay. Last term would be this 1 and this x cube. Okay. Again, there's a minus sign now. 5c3 is nothing but 5c2. 5 into 4 by 2 into 1 by 2 square, which is 1 by 4, and 2 cube, which is 8. Okay. This is along with x cube. Okay. So the coefficient, if I get rid of this x cube, what remains is nothing but the coefficient. You can see that there's a one in one place. Okay, this is a, but we already know the value of a. We just have to substitute and simplify. Okay, let us see what do we get. So this 2 and this will get cancelled, right? So it is minus 15 by 8, first term. The second term, let me just substitute this as minus 9 by 4. Fine. A is minus 9 by 4. So this 8 will get cancelled. 8 into 2 is same as 4 into 4. Already cancelled. Remaining terms, this minus will get this minus. So 9 into 5 is 45 divided by 4. Okay. Remaining term. 4 into 2 is 8. So remaining is minus 20. That's it. Okay. So what is this? I think the LCM you can take it as 8. Fine. So this is minus 15 itself. 4 into 2 is 8. So this becomes minus 90. This denominator is 1. So into 8 I have to do, right? 20 into 8 is 200. So minus 200. All are negative. So minus 295 by 8. So this will be your final answer. In the expansion of x cube minus 2 by x square whole power 10, find the following terms. So you have to find the x power 10 term, x power minus 5 term, and x power 0 term. That's it. Write the general equation, the general term, right? From that, we'll try to figure out. What is the general term? TR plus 1 is equal to NCR, say a power n minus r into b power r. So just write down the terms now. This is 10 CR. Okay. A, what is a? X cube power 10 minus r. Okay. It gets multiplied into b. B is with a minus sign, minus 2x square whole power r. Just to simplify it better so that we can combine the x powers, right? So it is 10CR. So this is x power 30 minus 3R. And there's another x power minus 2R coming from this. It is x power minus 2R into this, right? So it will get added, the powers. So remaining is what? Minus 2 whole power. That's it. Now what do you have to do? I have to figure out x power 10. That means x power 10. So this x power 30 minus 5R. This is nothing but 5R, right? This should be equal to x power 10. That means 30 minus 5R should be equal to 10, or 5R should be equal to 20, or R should be equal to 4. All I have to do is substitute R equal to 4 in the equation, right? So the term I need, so obviously I need with x power also. Whenever they ask coefficient, you can ignore the x power. When they ask the term, you just write the x power. So it is x power 4 into minus 2 whole power 4, okay, into 10C4. If you want, you can calculate that. It's not that tedious. So it's 10 into 9 into 8 into 7 by 4 factorial, 4 into 3 into 2, into 2 power 4. 2 power 4 is 16. Okay. So 4 into 2 is 8. This gets cancelled. 3, this gets simplified. Okay. Now 3 into 7 is 21. Right? 21 into 16 into 10 into x power. Okay. Just to multiply, you can just have 21 into 16. Okay. This will get 6. You'll get 12 plus 1, 30. So 6, 3, 336. So you should get 3360 x power. That should be your term with x power 10. Okay. Sorry, I've written x power 4 here. Okay. What we got is r equal to 4, not x power 4. Okay. Just to make this correction. So this is nothing but x power 10. Yeah. Okay, that's what I was thinking. How? What we did is we equated to x power 10 only and got. While writing down, I just wrote x power r. It's not x power r. It's x power, say, 3 into 10 minus 4. Okay, which you're going to get 6 into 3. Sorry, this is your equation. So you're going to get x power 30 minus 5r. Right? So if r is 4, 30 minus 4 into 5 is 20. So you're going to get x power 10. Make that correction. The coefficient of 1 by x power 5. Same. Instead of having x power 30 minus 5 are equal to x power 10, we have x power minus 5. Fine. So just equate that 30 minus 5r is equal to minus 5. See what you're getting. 5r is equal to 35 or r is equal to 7. Again, the same approach for the second one. Right? Simply substitute r equal to 7. So it is 10C7. X power we already know now. I should get x power minus 5 because I've taken 7. Or you write 30 minus 35, which is x power minus 5. Right? Next is what? Minus 2 whole power 7. So this is same as 10C3 minus 2 power 7. So to calculate this, what do you get? So we just need the coefficient, so I can ignore this power. This is 10 into 9 into 8 by 3 factorial, which is 6, into 2 power 7. 2 power 6 is 64. This will be 128. Okay. So 6, just to simplify this is 3 3s are here, and there's a 2, which will be 4. So 12, 120 into 128. Okay. So just to calculate it, how much we get, 120 times 128. We get 983,040 with a negative sign. So 120 into 128 is nothing but 15,360. Okay. There's a minus sign here, so all you're getting is minus 15,360. Okay. You can keep your answers as it is here, right? need not actually multiply, depending on the options. Okay. Usually they won't ask you to multiply such solution. The third subpart, now all you have to do is equate the power to 0. So x power 30 minus 5r should be equal to x power 0, the constant term. Okay. So 30 minus 5r should be equal to 0, or r should be equal to 30 by 5, which is 6. Let us substitute r equal to 6, so you'll get 10c6. Okay. So x power, we know we are going to get 0, 30 minus 30, right? Minus 2 power 6. Again, we can keep it as it is, 10c6 into 2 power 6. If you want, you can multiply. Right? So in the problem, right, the binomial expansion x plus k by x whole power 9. K is a positive constant, and the coefficient of x cube and x are same. Find the value of k. Now, using that, we have to figure out something else. Okay. First, let us try to figure out what is k. So the coefficients of x cube and x are same. So what should we do? Let us try to write the general term. From that, we'll try to figure out what is the coefficient of x cube and x. Or you can write the initial terms if you like. Okay. But the problem is, whenever there's in the denominator, right, you might miss some term. So it's easier simply to write the general term. So what is it? NCR x power n minus r into k by x power r. In this case, we are getting n as 9 because it's given, right? So this is x power 9 minus r. K, this x power r is in the denominator, that I'll add it first into k power r, right? Yeah. Just to combine the k terms and the r terms. So now look at this. 9cr x power 9 minus 2r. Now it's easy to equate. Okay. I want 9 minus 2r to be equal to 3 and 9 minus 2r to be equal to 1. So whenever these two are equal, okay, so I'm going to get the coefficients to be equal. So what is this? When does this happen? This happens when r is equal to 2r. So this side is 6. So when r is 3. This happens when r is 4. So when r is equal to 3 and r is equal to 4, right, we're going to get the coefficients to be equal. So let's equate it. So r is equal to 3, that means this is 4, right? Let me write T4. T4 is 3 plus 1, okay? And let me write T5. I'll just write a coefficient because these are equal, right? So we can ignore the x part. So 9c3 into k power 3. Okay. This is equal to 9c4 into k power 4. That's it. Right? So how to equate? So 9c4 k power 4 is nothing but 9c3 k cube. So k cube is common, right? Assuming k is not equal to 0, okay, because it's given that k is a positive constant, right? So k should be equal to 9c3 by 9c4. To simplify this, 9 into 8 into 7 divided by 3 into 2 into 1 divided by 9 into 8 into 7 into 6 by 4 into 3 into 2 into 1. I need not simplify the separate denominator, I can cancel like this. Numerator, I can cancel like this. All that remains is 1 by 6 by 4 or 4 by 6 or nothing but 2 by 3. So what is the value of k? K is equal to 2 by 3. You got k. Now what is asked? Using the value of k found in 1, find the coefficient of x power 5. Not x power 5 only in this, in the product. Okay. So let us try to figure out. Here. So 1 minus 6x square into x plus, let me just substitute the value of k, which is 2 by 3. 2 by 3x whole power 9. I need, say, x power 5. So 1 minus 6x square will remain as it is. So let me start with the decreasing order. Or you can start from below, but let us try to see what are the terms instead of getting confused. So x power 9. Okay. You can start from the other side, okay, and increase. but let's figure out. So it's 9c1 into x power 9 into 9 minus 1 now. Okay. So I'll write it down. So 2 by 3x. Okay. So this power reduced instead of 9, it became 8. Right. So overall power I just am interested. This is 7 step. Okay. That's why I said you can start from other side also, but it won't make a difference because again it will start from denominator 9. What do we want? We want x power 5. Right now we are at x power 7, which is higher than x power 5, which is of no use. Okay. Next term. 9c2 into x power 8, so it's 7 now. 2 by 3x whole square. Look at the power now. This is 7 and this is 5. Correct. Just because we got x power 5, I can't stop here. There's a problem. Okay. The next term will be x cube, but this x cube can be multiplied with this, right? X square. And we can get x power 5 again. Okay. Let us continue. 9c3, okay, x power 6 by 2 by 3x cube. Right? Now can you see this is x cube term? This will get multiplied here and I'm going to get x power 5. So only two terms. The next term, if you think of, it's already x power 3. It will go x, that's it. And the other problem is here, we don't have x power 4, something to multiply to get x power 5. Okay, that's it. Two terms, all I'm interested in. Let me just write it down. So this 1 into this term, okay, it is 9c2, okay, into 2 power 2 into x power 5. So there's a 3 in the denominator, which is 3 square. Now this minus 6 into 9c3 into 2 by 3 whole cube again into x power 5. X square here, x cube here, so you get x power 5. So what we are interested in coefficient, so I can just ignore this x power 5 and try to simplify here. It's 9 into 8 by 2 into 2 square by 3 square. So this 3 square will get cancelled. One of the two will get cancelled. Remaining 6 into 9 into 8 into 7 by 6. Okay, 6 and 6 is get cancelled. This is 2 cube by 3 cube. Now 3 square will get cancelled, but 1 3 will remain, right? So what is it? 8 into 2 is 16 minus 8 into 7 into 8 by 3. Okay, you have to calculate again. So 64 into 7, which is 7 4s are 28, 7 6 are 42, 44. 448 by 3. Just to simplify, this is minus 48, right? So minus 400 by 3. So k is 2 by 3 and the coefficient what we are getting is minus 400 by 3. Given that p, q, r are the second, third and fourth term of this expansion, right? So in the ascending powers of b, so this is usually we take the same order, we take the highest power, decreasing power of a and ascending power of b, right? So okay, show that this is equal. Okay, fine. The second part we'll look at later. First, let us try to figure out what is the second term, what is the third term, what is the fourth term. So T2 is nothing but the second term. Okay. T2 is P of 1 plus 1. Fine. So it is NC1. So let me write down what is N. It's N itself. Nothing, no value is given, right? The second subpart N is given. We can't use it now. So NC1 into A power N minus 1 into B. This is nothing but P. Right. Third term, T2 plus 1, NC2 A power N minus 2 B square. This is nothing but Q. Next, T4, T3 plus 1, NC3 A power N minus 3 BQ is equal to R. Right? Now, I just have to check for this result. So let me just take what is given there, PR by Q square and see what I get. So I have to evaluate PR by Q square. What is PR? Product of these two. So it is NC1 into NC3 into, let me combine the A powers. A power n minus 1 into A power n minus 3 into B into BQ. Right? Denominator. Right? Q square. Q is nothing but NC2 whole square. Each term square I'll write. So A n minus 2 whole square and B square whole square. B square whole square is B power 4. Can you see that it will get cancelled? A power n minus 2 is nothing but A power 2n minus 4. Okay. Can you multiply these two and see? A power m into A power n plus n. Here also you will get the same. A power 2n minus 4. So these two will get cancelled. All that remains is the binomial coefficient. We just have to simplify and see whether we're getting this result. Let's see. NC1 is n itself. NC3, n into n minus 1 into n minus 2 by 6 factorial. So here also n. Denominator. Whole square. N into n minus 1. Right? Is it NC2? N into n minus 1 divided by 2 whole square. Right? So let me try to simplify. Numerator is n square into n minus 1 into n minus 2 by 6. Denominator is n square into n minus 1 square by 4. N square will get cancelled. One of the n minus 1 will get cancelled. There's one 2 here common. So 2 3s are 2 2s are. What remains? I'll take the denominator to the numerator by taking the reciprocal. So it is twice n minus 2 by 3 times n minus 1. Okay. That is the result we wanted. That's the final answer. Now, for the second sub part, all we have to do is substitute now because the values are given. We have given P, Q, and R. Find the value of n. So for this, we'll directly equate P, Q, and R. P is what? 8. And Q is 24. So 24 square. And this is 36. Right? Let me try to simplify here. 24 square is 24 into 24. So 8 3s are. Right? So 3 12s are. Right? 12 2s are. So all that this side is equal to the right hand side is half. So just cross multiply, try to simplify. So 3 into n minus 1 is equal to 4 into n minus 1. Or 3n minus 3 is equal to 4n minus 8. N is equal to, take minus 8 to the other side, it will be 5. That means when n is equal to 5, right? N is equal to 5 when these values are 8, 24, and 36. So 20 into 8 is 160, right? So it comes out to be 160, 250 minus 265 by 8. The final quotient what we're getting for x cube is minus 265 by 8. So what we did is first we used the information given to figure out a, right? From that we got an x cube. So there's a lot of calculations involved, right? Whenever we have such problems, right? So try to make more neater notes so that you get your final answer correctly. If there are multiple options, right? So at the end, if you end up with the final wrong option, right, you can't really do much. So we know how to find the middle term, but in an expansion, we are interested in what is the greatest term. Not only what is the middle term, but what is the greatest term. If it's a simple expansion, right? Something like say 1 plus x whole power say 20. Again, if you're not putting values for x, okay, we're only putting looking at the coefficients of x, right? We can see that all are just binomial coefficients, correct? They start from 20C0, 20C1, so on. So you know the middle term 20C10 there, right? Middle term would be the maximum. Suppose now, just imagine instead of this 1 plus this, I have 2 plus x, right? Now there's a factor of 2 which is getting multiplied. Initially it starts from 2 power 20, so on. What if I have, say, 2 and here 3? Now you can see that the factors are getting multiplied and divided, right? Where is it maximum? So the whole idea is to figure out which term is maximum. Okay. So it even can be the third term or fourth term in a 100-term series. Okay. So it's not that it should be the middle term. So how to figure this out? Okay. So by definition, what do you mean by greatest term? That's all we try to figure out. Suppose I have a general term, this TR, this. Okay. So I know this term. Suppose this TR plus 1 is the greatest. So what will happen? If this is the greatest term, the previous term should be lesser than this. This is greater than any term. Correct. So what I do is the previous term, I'll just say this ratio should be greater than. It's obvious, right? Because TR plus 1 is the greatest term. I'm assuming that. So TR plus 1 by TR should be greater than 1. You may ask me if it is greater than any term, why are we taking TR? Well, we should be able to find a ratio. Okay. See, this TR plus 1 are involving this binomial coefficient like NCR, so on. So if you take them far apart, right, there won't be terms which you can cancel out. Okay. Let's look at this now. Suppose we are talking about the expansion. Say, let me take A and B. So that is A plus B. Okay. A plus B whole power n. Okay. Now what is TR plus 1? This is NCR into A power n minus R BR, right? Denominator is NCR minus 1 because we are talking about TR. Now it's one term less, right? So this is A power n minus R minus 1, okay, into B power R minus. This should be the. Look at the terms. Now easily we can cancel this. BR minus 1, right? This should be B. Correct. Now this here, if you divide, this should be A. Correct. So what are you going to get? So this will be A plus 1. This will be nothing but A power n minus R plus 1. Right. So therefore it will be A. Look at the term. I got B by A into NCR by NCR minus 1. So this is n into, right? We can write directly n factorial by say R factorial into n minus R factorial. Okay. So NCR minus 1 again n factorial divided by R minus 1 factorial into n minus R plus 1 factorial. That is n minus R minus 1 after simplification. The n factorial will get cancelled. Okay. What are remaining? Let's see. B by A. Remaining term. Here R factorial is R into R minus 1 factorial. So R will remain here. Okay. The denominator I'm going to get R. Now n minus R factorial, again, if I write it as n minus R plus 1 into n minus R factorial. This will get cancelled, n minus R. So that will go to the numerator. So it will be n minus R plus 1. This should be the one. Can you see just by taking consecutive terms, the ratio becomes much easier. If you want, you can remember this as a formula, but I won't recommend it. Right? What you can do is for any problem, right? Any expansion given, you simply take the greatest term. Simply use the definition itself. Correct. That will be much easier instead of say simplifying this and try to figure out what is R. Okay. What you could do is say A and B again depends on the sign of A and B. Okay. If one of them are negative, everything changes. You can cross multiply. Okay. Or have this simplified by n plus 1 R by R minus 1. Okay. Is greater than A by B, assuming all are positive right now. Okay. And take 1 to the other side. Okay. Then what you can do is n plus 1 by R is greater than A by B plus 1. So now you can see that we can get a condition on R. It should be greater than so and so. Then you will get the value of the greatest. But instead of remembering it as a formula, right? What we can do, always use this definition. Just take the general term, simplify it every time, right? And directly get your condition. Much easier. No need to remember a formula, and you'll never go wrong. Here, in case you don't remember the formula or there are negative terms involved, right? It might be a bit confusing. Sometimes what they ask is only the magnitude. What do I mean by only magnitude? Suppose if it is A minus B whole power n, it doesn't matter if I get a negative sign. That means even if the term is a minus A power say R into B power n minus R, whatever this term is, I'm interested in the value of this, right? I'm not interested in this sign, the magnitude, correct? In that case, you won't have an issue with the sign. But still, I would prefer, like, you can just take this as mod. That mod is greater than 1. So use the definition, try to figure out directly and get your answer. Much easier. Or else, if you want, just continue this, get a relation in R, right? And then try to use the form. Okay, let us try the greatest term in this expansion. You can see that this term is outside, right? It's just multiplication. You can just ignore this term because the greatest term will come from this side. Okay. Just to write the greatest term, we probably have to multiply root 3. That's all. But it won't change the equation by any means. What is the greatest term? I think for this, we really need not use the TR by TR plus 1 because look at this. This is root 3. Let us look at the terms. This is 1. First term is 1. Second term, what is it? NC 1. Right? We know N, so it is 20. 20C1 into 1 by root 3. Okay. Next should be 20C2 into 1 by root 3. Okay. Square. Now, if you continue like this, at one point of time, you may have a rough guess which might be greater. Okay. So, just to show how a theorem works or a method, we'll take, say, TR plus 1 by TR for this expansion. So, what is this? NCR by NCR minus 1. Now, first term is 1. Okay. So, it doesn't matter now. Second term. Second term is b power r. B is what? 1 by root 3 whole power r. Denominator is 1 by root 3 whole power r minus 1. This should be greater than. There's no negative sign involved anyways. Okay. Let's try to simplify this. Now this is 1 by 3 whole power r minus 1 into 1 by root 3. Right? So it will get cancelled. So what remains is 1 by root 3, which I'll take the other side. Fine. What remains here? You've already seen this ratio. If you want, we can just simplify it quickly once again. R n factorial by r factorial into n minus r factorial. Denominator is n factorial by, say, r minus 1 factorial into n minus r plus 1 factorial. So n factorial cancel. R minus 1 factorial here, r will remain. If we cancel this, n minus r plus 1. Just taking the reciprocal because it's the denominator, right? So we'll get n minus r plus 1 by r. I'm trying to figure out what is r, right? So just divide this. What is it? Or you can cross multiply because r is a positive number, no issues. So it's n minus r plus 1 is greater than root 3r, or n plus 1 is greater than root 3 plus 1r. So r must be less than n plus 1 by n plus 1 by root 3 plus 1. What is n? We already know. We never substituted. So this should be less than 21 by root 3 plus 1. That's it. So what is 21 by root 3 plus 1? Okay. We need a rough estimate. Correct. So the root 3, we can just take it at 1.7. So 21 by, say, 2.7. Right? If you want, you can directly divide by, say, 7 and do it. Right? Just a rough estimate taking by 2. But I'll just directly divide and tell you what it is. 21 divided by 2.7. Right? You get 7.77. Okay. R must be less than 7.77. So R must be equal to 7. The greatest term there, right? Greatest term there will give you the value of R. To go lower, what will happen? It is not the closest value. By taking the ratio, what we got is the closest value. Obviously, R can't be this value to be maximum, right? But R should be equal to 7. That will be our answer. So if you want the greatest term now, okay, what you have to do? Take the TR plus 1 term here. We know R is 7, correct? Just put R equal to 7. So it is 20C7 into 1 by root 3 whole power 7. And there is root 3 outside. So just make sure you multiply it with that. That's it. This would be your greatest term. Even if you do by formula, you get the same. Now the greatest term of this expansion when x is equal to 3 by 2. Now we have to find the greatest term. Now the value of x is also given. Okay. So doesn't mean that we simply substitute x and write it whole power 9 because there won't be terms then, right? First we have to write the terms. So same method, tr plus 1 by tr, right? What is it? Tr plus ncr into, say, a power n minus r into b power r divided by ncr minus 1, 2 power n minus r plus 1 into 3x whole power r minus 1. This should be greater than 1 because I want to find the greatest term, right? So this is the r I'm trying to figure out. Now, when is this greater? Okay. Let me simplify. This is nothing but 3x. If I divide this, this is nothing but 2. Right? So what do I get? 3x by 2. Now remember, x is a positive quantity, so I can cross multiply. But still, here is n minus r plus 1. You already know this. I've done it multiple times. So let me just write it down. This ratio should be greater than 1. What is x? X, we already know it's 3 by 2. So simply we can substitute here. Okay. So n minus r plus 1 by r, taking the other side, is 2 by 3 into x. Okay. So x is in the denominator now, 2 by 3x. So it will be 4 by 9. Okay. Now we know n also. What is n? N is 9. So let me just replace n by 9. Now let us try to simplify. So 10 minus r is greater than 4 by 9r multiplying. So 90 minus 9r is greater than 4r, or say 13r is less than 90. So r must be less than 90 by 13. 90, sorry, 13, this is approximately 6 point something. Okay. Because 13 5 is 65, 13 6 is 78. If I do 13, say 7s, it will cross 90, it will be 91. Correct. So what we want is this value. So it's 6 point something, we did not even find the value. Okay. So what can be r? R should be equal to 6. Now we have to write the greatest term. So put here, say D7 is 9C6, correct? 2 power 9 minus 6, which is 3 into 3x whole power 6. So this will be a greatest 9C6 to cube the 3 power 6. Show that 3 power 2n plus 2 minus 8n minus 9 is equal to 64. Usually we get divisible by smaller numbers, right? So 64. So you can't directly see somehow how to get 64. Because there are multiple proofs for this. I think you can even prove this by induction. Okay. But we have learned binomial expansion. So let's try to use that. The first thing you have to figure out is how to get 64 somewhere. Now 8n, if I assume, so n should be some multiple of 8 to get 64. There's no way I'm going to get 64, even for a term. So somehow in this expansion, if I have to show that this is divisible by 64, here many terms should be 64. Okay. That would be my first hint. So what is the first term? 3 square into 3 power 12. Okay. Or it is 9 into 9 power n. Okay. As soon as you write this, 9 into 9 power n, you should get your hint. Because this is nothing but 9 into 1 plus 8 whole power n. As soon as you write this binomial expansion, your problem is solved. What will happen? Why did I write 1 plus 8? Because I know the terms will be, first will be 8 power 0, 8 power 1, 8 power 2. As soon as I get 8 power 2, that is 64. That's how I thought of 8. Okay. 8 power 2 and beyond, right? All the terms will contain 8. That's it. So this is 9 times. What is the expansion? 1 plus NC1 into 8, NC2 into 8 square, NC3 into 8 cube, and so on. Okay. Now I want to check if this entire thing is divisible by 64. Minus 8n minus. Can you see that? 64. All these terms after 8 square, each and every term is divisible by 64. no issues. So I have to check for the rest of the terms. What is the rest of the terms? So this is 9 and this is NC1 is N. So 8N into 9, 72N. Okay. Remember, rest of the terms I've taken care of. All are divisible by 64. I did not check for them. So minus 8N minus 9 is there. 9 and 9 will get cancelled. I have to check for 64. Look at the remaining term. This is 64N by 64. Even this is divisible. Okay. So I just prove each and every term, whatever there in the numerator, is divisible by 64. You can do this by induction by assuming that this is divisible by 64, okay, and taking the next term and proving. But using binomial expansion, you could see it's very direct. Correct? As soon as you figure out this is 1 plus 8, what happens is this 9 gets cancelled here, okay, and this 8n again becomes a factor of 64. This is 8n into 9. This is 8n, so it will come out to be 64. Find the last two digits of 17 power 256. In fact, you can even find the last three digits, right? If you're trying to figure out, but it will involve more of calculations. You need probably a calculator just to reduce the calculations. I made it last two digits. The idea here is again using binomial theorem. Now, if you directly use binomial theorem, what will happen is, suppose you are doing 10 plus 7. Okay, you can't calculate the terms. That is the first one. Because the powers increase very rapidly. And if you have two numbers whose powers are very increasing rapidly or decreasing, so at one time we'll have say 10 power something and 7 power something, right? Multiplication becomes a problem. Even though 10 power multiplication is simple, just look at the terms now. Okay. First term is 7 power, say 10 power 250. Let us start with increasing order of 7 powers. Okay. So that this is 10 power 256. Okay. 7 power 0. And 7 power 1 into 10 power 255. Okay. Now you may say, okay, I don't need this term because this has so many zeros. I need the last two digits. Okay. So let's think of when can I get last two. 10 square into 7 power. This is 254. That's when I get last two digits. How do I figure out this sum? There is no particular. You can use number theory and stuff, right? But again, it's easier there to get last digit rather than last two digits, okay? Because we have not learned anything there on number systems or number theory, right? So let's not try to use that. Well, let us use binomial theorem. Okay. So instead of directly writing 17 as 10 plus 7, what we do is we write 17 square. So 17 square is what? 289. Because power is even, we don't have an issue. Right? Even if power is odd, what you can always do is, see, if it is 257, you can always split it into 17 into something. Okay? Depends on your problem. Okay? But just in this case, it's any even. So it is 17 square power 128. Okay? That means it's 289 power 128. Why did I write this? Just look at the number. It's 290 minus 1 whole power 128. Right. So 290 power 128 minus. Okay. Next is 290 power 127. I'm ignoring the binomial coefficient, etc. Okay. We're not coming to that yet. There is 128C1, etc. I just want to figure out what this is. Okay. Next should be 290 whole power 126. So, okay. Can we look at the numbers? One advantage of doing this is the other term is 1. So I need not worry about two numbers increasing and decreasing. Okay. Last time you saw that when 10 was like 10 square, the number was very close to, say, countable numbers, right? 100. But the other term was 7 power 254, right? It was very tedious. Now you can see I need to worry only on one side. I'll show you why. Okay. Look at the powers here. If this is power 128, doesn't it mean it has 10 power 128 also? Because it is nothing but 29 power 128 into 10 power 128, correct? So it has 128 zeros. So this term will certainly not contribute to the last two digits because when you add them, they will have only zeros. Even this term won't contribute. Even this term won't contribute. You get the idea. So all I have to check is for the last couple of numbers. Let me write in the reverse order. Okay. So or let me write this is one. Okay. What is the previous term? See, this is one because it's 1 power 128. Okay. So let us not miss the sign because it's a negative number. There will be a slight confusion. If it was 291, it would be much easier. All the terms are positive because it's negative. A bit confusion would be there. Okay. Let us write powers. Next is minus 1 for 127 into 290. This is certainly going to contribute, right, to my calculations. But now let me write the terms correctly. NC1 or 128C1. Right. Next term would be 128C2 into 290 whole square. Okay. We'll just figure out what we need to do. So this was minus, this will be plus anyways. Right? So because it is minus 1 whole power 126, so even. I'm just interested to figure out which is the term that is contributing to my last four digits. Now, this one will have two zeros. You may think that this doesn't contribute. Okay, we'll come to this later. This is some say some integer I into 100. Okay. Some integer. I'm not sure what the integer is. If you want, you can calculate. It's not that huge, but it will take some time. Let me look at the other terms. Okay. Here, what do you have? This is minus 128 into 290. Okay. Plus 1. Great. So we can multiply 128 and 290. Let me just tell you what it is. 290. I'm going to get minus 37,120. To be honest, you need not even calculate this because okay, let me not calculate the unnecessary calculation because I reduced this last three digits to two digits for the reason we need not do a lot of calculations. Right? Okay, can we look at this number? This is 0. What is the unit digit number in this? It should be 8 into 9. There's no other number contributing to this last. It should be 2. I don't know what the previous numbers are, right? But these, it should end with 20. That's for sure. No doubt. Okay. Now, let me take, say, some number, like, say, 4440. We already know the answer. The answer was actually 37,120, but I'm not even considering the real number, just a random number with a negative sign. Plus 1. The usual mistakes what we do is this is minus 20, this is plus 1. We say the last is 2 is 19, which is certainly wrong. Okay, because this involves a negative sign. That's why I said this term here, right? Even though it feels like it's not important, we need to figure out. Okay. Look at the term here. This is 100 into I. Okay. So the digit, let us take some random number, whatever 333. Okay. It might be much higher than this. See. Now, when there is minus sign, this number is certainly greater. Okay, no doubt about it, because 290 square would be almost greater than this. So this double zeros, even though it's not contributing here for the last two digits, can you see that if I subtract, what do I get? 300. Last digits I'll subtract 420. Again, even though this carry, it won't affect the last two digits. I'm going to get 8. So because this is a negative number, I'm going to get 80 from these numbers. So what would be the last two digits? 80 from here plus 1. So the last two digits would be 80. I hope it's clear. Right? So in case you had a calculator, etc., or you are going to multiply, you can just multiply, you can add these numbers, last three digits. Now here, if you add, you will get the last three digits. You did not consider the next number, right? So next number would have a negative sign, which will get corrected by the previous term, because the previous term would be larger. You can just take an example and check. So by this, you would get the last three digits. Just because to avoid calculations, right? So we did this, correct? So just remember, whenever you have minus sign, because what is happening is you're not actually getting 20, you're getting 100 minus 20, because this will contribute to the 100 part. So what number comes out is 80. Okay. So that's why I said if it is plus, right? Plus you can totally ignore this number. You need not even consider this number. If it was plus, all the signs is positive. Directly you would have got 20 here and plus 1, you would have got 20. So if I is the integral part of this and f is the fractional part of this number. So we don't know what is n also. So we just 2 plus root 3. Okay. Basically, it's in some irrational number and we're raising to some power. So what I'm getting is some integer part and some fraction. Right. So what I have to do? I have to find out what this is and prove that I plus f into 1 minus f is equal to 1. Now this is very clear. Look at this. This integer, it looks like it's pretty huge, right? Into 1 minus it somehow is going to give me 1. So we have to figure out how is that possible. The whole thing lies on figuring out what is 2 minus root 3 whole power n. Okay. Why I'll tell you. See, what is 2 minus root 3? Isn't it a number between 0 and 1? Okay. So suppose if this is a number between 0 and 1, even if I raise it, suppose let me take this as say some h. Okay. Some h. Even if I raise it to the power of n, it will remain a number between 0 and 1. That means if I write this as some integer and fractional part, there won't be any integer part. It will be 0. Only that remains is fractional part, which is equal to h. Why am I telling you this? Because if I multiply these two, or in other words, instead of multiplying, let us add. Okay. Because I just want to show you, if I add these two, what I'm going to get. Right. If I add these two, let us look at the terms. First is 2 power n. Right. Next term is 2 power n into n. Sorry. 2 power nc1. Let me write it in order. nc1. 2 power n minus 1 into root 3. Irrational term. Okay. Next would be nc2. Okay. So 2 power n minus 2 into root 3 square. And this root 3 square, this term won't be irrational. Okay. Similarly, there's a same terms with a negative sign. It will be 2 power n minus n into 2 power n minus 1 into root 3. Next will be plus. Okay. Just look at the terms. Whichever is the irrational term will get cancelled. So what I'm going to get is I'm going to 2 power n. Okay. Next term, whatever this is twice 2 power n. Okay. Again, this is twice whatever this term is, but it's not an irrational number. Root 3 square will be nothing but 3 now. Right? Okay. Next term we can think of odd power term of root 3 is an irrational number which will be cancelled. Even power term would be a rational number and it will remain. Okay. Basically, what I'm showing you is this sum is equal to some, say, some I dash, some integer. Agreed? But what did we do? We just added I plus I dash is nothing but say I plus f and h. F is a number which is between 0 and 1. I can certainly say it's not equal to 0. Okay, because we know that there's an irrational part here. Again, h, again I can certainly say it's not equal to 0. Both are not equal to 1 anyways, and they're not even equal to 0. So they're strictly between 0 and 1. But if I add them, I'm getting an integer. And I can get only one integer. So f plus h can be equal to only 1. Why? If they is equal to 2, this sum is not possible, right? Let us look at this. Add these two inequalities. Add it. What I'm going to get? 0 on one side, f plus h is less than 2. There's only one integer which is lying between 0. Why should it be an integer? Because this is an integer, this is an integer. So the remaining part should be an integer. Right? We know multiple things here. One is f plus h is equal to 1. Okay. Fine. That means here, what is I dash? This was I dash, correct? I dash. I dash is same terms multiplied. Okay, we are adding the same term. So it is 2 into all these terms, 2 power n, 2 power nc2, 2 power n minus 2, so on. So it is 2 into some integer again. Let me take it to say I double dash. Okay. It's not important. All I wanted to show is because it's 2 into some integer, this is an even. If this is even, so I have now an equation which is even number is equal to I plus 1. Obviously, if I subtract an even number by a 1, I'm going to get an odd. So we had to prove that this is equal to 1 and it's an odd integer. We already ended up proving that I, or the integer part, is an odd integer. Okay. And let us simply see what is this. Now, what is 1 plus f? Sorry, I plus f into 1 minus. Now, do we know what is h? H is nothing but 1 minus. Correct. So, what do I want to do? I plus f into h. That's it. So, I already know what is I plus f. I plus f for the term 2 plus root 3 power n. And h is nothing but 2 minus root 3 power n. The whole, I got this idea just because I knew that the product of these two, right? The product is nothing but 4 minus root 3 square. So, it is 1. So whenever I saw that a 1, right, we know this, these are conjugate pairs, so the product turned out to be 1. That's the reason we first thought of taking this. Okay. So I was thinking of multiplying it directly and getting the result, but it's easier to understand what is the value of taking this as x. Okay. Now we have proved that this product is equal to 1, and we also know that I should be an odd integer. Now we are going to look at binomial coefficient. So we are doing a lot of calculation in the binomial expansions, right? So we need to know some of the properties at least of binomial coefficients. You would have learned some in permutations and combinations, right? But let's just look at some more, or let us just revise what you've learned. So NCR, you already know this, is say n factorial by r factorial into n minus r. Now I'm interested in what is NCR by say NCR minus 1. This also we have seen in a couple of problems. So you would know it's n factorial by say n say r factorial into n minus r factorial. Right. So it would be n factorial by r minus 1 factorial into n minus r minus 1 by definition. Right. So n factorial get cancelled. So numerator by property of factorial, we can write this as r into r minus 1 factorial. This will remain n minus r factorial by, again 1 by, we can write r minus 1 as it is. The remaining term we can write as n minus r plus 1 into n minus r factorial. Again, n factorial can be written as n into n minus 1 factorial. So we can see there are common terms which can be cancelled out. Right? All that remains is n minus r plus 1 divided by. So this is one of the properties. I don't want you to remember. You can always divide and figure out. Okay? But you should be able to figure out. The thing is, whenever you have coefficients very close, this ratio is very important. You can see one more example. Instead of having NCR by NCR minus 1, you can even think of n minus 1 CR minus 1. Good luck. Look at the numerator now. It's n factorial by r factorial into n minus r factorial. Denominator is n minus 1 factorial by r minus 1 factorial into n minus 1 minus r minus 1. Right? Now, n factorial doesn't get cancelled because it's n into n minus 1. Okay. So, what will remain is n. Right? Similarly, here, there will be r into r minus 1. So, r will remain. This is what? This is nothing but n minus r factorial itself. N minus 1 minus r minus 1. Right? This will get cancelled. Right? So, what remains? N by r. this is, if you can remember, it's okay. But others, again, it's simple division, nothing else. So NCR by NC minus, sorry, NCR by N minus 1 CR minus 1 is nothing but N by R. Okay. One more, this property is very important. Okay. NCR plus NCR minus 1. What is this? Because every time deriving this is not so direct, even though it's just addition. Division there, what will happen is you just have some factorials you have to rearrange. If you remember this, it's very good. So this is nothing but n plus 1 CR. It gets reduced very nicely. It will be n plus 1 CR. Can we see how do we get there? Okay. Look at this. This is n factorial by r factorial into n minus r factorial. Again, we're going to do the same thing. We're trying to figure out what are the common terms. This is r minus 1 factorial into n minus r, write n proper, n minus r plus 1 factorial. So take the common terms outside, n factorial, r minus 1 factorial into n minus r factorial. These are the common terms. Okay. What remains inside? N is gone. Okay. R factorial, r remains. N minus r factorial is gone. Second part. N factorial is gone. R minus 1 factorial is gone. Remaining is n minus r plus 1. Take the LCM. What do you get? N factorial by r minus 1 factorial into n minus r factorial. Here, LCM is r into n minus r plus 1. Numerator will be the same. N minus r plus 1 plus r. R and r will get cancelled. Now look at the terms. Look at the terms. Let me try to combine. N into this product. N factorial into n plus 1 is n plus 1 factorial. Great. R minus 1 into r. So that is again nothing but r factorial. That's how we're getting, we split it also. N minus r into this term. Correct. So it is n minus r plus 1 factorial. Can you see this is nothing but n plus 1 CR? Write the formula. What is it? N plus 1 factorial by r factorial into n plus 1 minus r. Both sides, the 1 and c. Okay. So this is an important property. Okay. It's easier, instead of doing a calculation here, it will take some time. So it's easy to remember. So basically, this n should be same. It's r and the next term. Okay. So if you have, say, some other terms, okay, you should be able to figure out what are they. So one simple, I think, problem you can take, then you'll understand. So suppose we have, say, NCR plus 2 times CR, oh, let me not take 2 times, and 2 times NCR minus 1, okay, plus NCR minus 1. Now, in this problem, they can even give you the value of n instead of randomly giving. Okay. So instead of calculating each of the values, look at what can be done. I'll just combine the terms NCR and NCR minus 1. Right. And I'll combine the terms NCR minus 1 plus NCR minus 2. Because I want to use the property, that's all. I want to use this property. Correct? What is it according to the property? This sum is n plus 1 CR. And the other term is n plus 1 CR minus 1. Correct? The n increases, okay, and r is the highest power as long as they consider it. Correct? Again, we need not stop here. Look at it; it's still in the same format. Both are n plus 1, so it will be n plus 2 c. Can you look at it? Instead of calculating 4 terms here, we directly can figure out one combination term. Okay. And I've given a simple example here. There might be much more terms involved. That time, the easiest way to solve it is by simplification, okay, by doing something like this. So please make a note of this problem. One more thing in the expansion, right? Just now, because we have learned what is NCR and NCR minus 1, the combinations, right? So if this is n, right? Just look at the expansion. This is NC0, which is 1, right? NC1 x, NC2 x squared, NC3 x cubed, so on. Okay. up to NCN x square. Have you ever wondered what is the sum of NC0 plus NC1 plus NC2 plus NC3 so on up to NCN? Correct. Now don't try to use the previous what we learned. Here, just figure out how do you get from here to here. Okay. All we have to do is put x equal to 1. Correct. To do that, you're going to get 2 over n. So this is actually a standard result, right? The sum of all the binomial coefficients, look at this. NC0 plus NC1 up to NCn is nothing but 2 over n. Okay. Similarly, look at this, one more result. Instead of x equal to 1, here what we did is put x equal to 1. Put x equal to minus 1. What are you going to get? This side is 0. Other side, NC0 minus NC1 plus NC2 minus NC3 plus NC4, so on, continues. NCn, do we know the symbol? Again, it depends on n. Correct. Now, what do we know from this? Just let me take the terms on one side, NC1 plus NC3, so on. And here I have NC0 plus NC2 plus NC4. Can you see that? All the even terms, or it should be equal to all the odd terms, irrespective of the value of n. So what does that mean? So I have two terms which are equal, correct? If I name each of these terms as some I, that means 0, okay, this 0, okay, what give me is some term is there I, and there's another term which is I. That's why it's 0. Correct, both are equal. What does that mean? We knew in this equation, the even portion, the odd portion are added, correct? What do you know? So I plus I, I'm using the equation 1 here, okay, equation 1. I plus I already know is 2 power n. Correct. So I can get to know what this I is. I is nothing but 2 power n minus 1. Because 2I is 2 power n, I should be 2 power n minus 1. That means each of the sum of odd terms or even terms is equal to 2 power n. So now these two results you need to remember, that's it. There are much more results which you can get. You'll learn some basic calculus. Then you can differentiate this. Okay. Just think about differentiating this equation. Okay. And then putting x equal to 1. Then see what results you have. Put x equal to minus 1. What do you get? Okay. Or you can integrate them. So a lot of other results. Or you can multiply 1 minus x and this and figure out what terms you get. Okay. We'll come to that later. Probably next year we're going to learn all those equations. It's not that important right now. Okay. What you can see here is, suppose I give you a problem again. So 8C1 plus 8C3 plus say 8C5 plus 8C7. Now you need not sit and calculate all of these terms. Now you may think 8C3 and 8C5 are not that complicated. Yes. But what if I give you more powers? Start from 12 or something, right? So what are you going to get here? This is nothing but 2 power 8 minus 1, directly 2 power 7 without any calculations. It's 2 power 7 or 128. Okay. Because this is nothing but sum of all the odd terms, right? Odd terms of the binomial expansion. So you can make a note of these things. Okay. So whenever you find sum of such terms, try to look for what properties you already learned. Either probably somewhere along the lines of 2 power n you have to use, or probably you have to use say NCR plus NCR R minus 1. Okay. Or if you're not able to figure out any one of those, you can sit and calculate.